say.
Yeah, it's a great town for that. Thanks for coming out this afternoon, everyone. We're hoping we got some really good content to show you guys. And one thing they didn't tell us, we're a couple of Canadians, they didn't tell us how hot it was going to be out here. So, you know, if you're walking by and see a puddle of water by there, and just wave to it and say, "Hey, Colin," I'm sure he'll be doing okay.
Don't laugh, it's only 40 degrees where we're at right now, so in Fahrenheit, I had to think of that. 8 degrees Celsius, so yeah, it's beautiful outside. This is great, love it.
Yeah. Well, we've got a nice lively audience here. So one of the things that they tell me is if you need some help relaxing, all you got to do is just picture us in our underwear, and that'll take care of business.
I don't know how bloody relaxing that is, guys, but hey, to each their own.
So we're going to talk to you about managing Microsoft Exchange 2013 and Microsoft Lync with System Center. My name is Brad Bird. I'm a senior System Center and virtual machine architect with Sysdel Technology. This is my colleague Derek Kerr. He's a Lync MVP as well. I'm a data center and private cloud MVP. We both work for System Center and Lync service provider out of Ottawa, Canada. We're very happy to come out here to New Orleans to present to you today.
We're not 100% cake, though. We do have offices in Atlanta. Just want to stipulate that.
Yeah. So just to set the stage, we're going to start things off by talking about what are the different things you ought to be thinking about, what considerations might you have when considering virtualizing a workload like Exchange. Then we're going to talk about that same concept, virtualizing Lync 2013.
And this is kind of going on the whole TechEd stuff that we're seeing here this year, right? The two main verticals we're hearing a lot about is virtualization, cloud, and UC stack. So we wanted to reiterate some of the capabilities, some of the best practices around virtualizing workloads of this type, Exchange and Lync specifically. Then we'll dig into some demonstrations as well.
Yeah, if we figured, you know, it's enough chat after that, we'll get into the hardcore stuff and show you guys how to manage this stuff with Microsoft System Center and 3 different platforms over there. So to kick things off, we'll talk about Hyper-V. So have any of you seen this thing called System Center, called Windows Server 2012? Yeah, they're talking about it a little bit, eh? A lot of things come out of Server 2012. In particular, they beefed up the Hyper-V support, right? Before you were able to support up to 4 virtual procs. Now you can get more than that. You can also support up to 4 terabytes of memory and 320 logical processors, right? So it's very highly scalable. They've also included some cool new features like the capability to do NIC teaming in the operating system, some other really
server
nice
I/O offload, dynamic queuing to the CPU for interrupts. If you guys want to see the compete slide against some of the other Hyper-V vendors out there, come talk afterwards and we'll show you some exciting numbers around that.
Right. So compute's one thing, but you got to keep all these VMs and those workloads somewhere. So what they've done is they've actually beefed up the storage capability, right? You can support up to 64 terabytes of storage for each one of those virtual disks that you have. And
also, on top of that disk, realize that some of the SQL transaction capabilities are in the new file format, which give us the disaster recovery scenario if the power goes off in a Hyper-V environment. There's a log file where the transactions are stored before they're played against the actual disk itself. So there is resiliency native in the new file format as well, which is key to understanding the technology advancements.
Right, and with that capability as far as storage for things like mobility, when you're moving those files around, because if you have to for a live migration or something like that, you've got this offloaded data transfer capability, which was previously only possible as a capability through something like SAN-to-SAN transfer to get that kind of speed.
How many try to move Hyper-V images in 2.0? You have to do the export, you got all the files, you got the snapshots, all that stuff. Now we can actually store it all within inside the single file, and we can actually use multiple locations where we can data configuration in one location and then storage in another location as well. It's pretty slick.
Okay. Along with that, we got some new increases to the networking capabilities, right?
Yep. Yeah, we have some. Actually, one of the cool things from a ISV or a tenant perspective is the ability to have multiple subnet masks the same with inside your host cluster. So if I have customer A being 192.168.100x, I can have 16 customers all utilizing that same subnet mask. Basically, what occurs on the host is an encapsulation as it gets passed from the host into the layer where the host is residing. So if my host is on 172.16.x.x, that's what we encapsulate in order to do network transmissions across between hosts and out to the internet, but still keep logical separation with our tenants.
Right. So it allows a lot more capabilities around sort of hosting type or cloud type scenarios to get into that sort of space. But beyond just Server 2012, we're talking about virtualizing Exchange. So what are some of the reasons that you might actually even consider virtualizing Exchange? Up until the present version, hearsay from customers that we've talked to really haven't been considering taking Exchange as a workload and virtualizing it. Well, what are some of the reasons that you might actually consider that to begin with? To get things started, today, if you're looking at deploying an IT workload, whether it be Exchange, whether it be SharePoint, SQL, the first question in your mind is, okay, how many servers am I going to need for this? Are we talking physical servers? Because that's an old way of thinking, right? We know virtualization has been around for a long time. So the thought process, which we see more with customers, is let's consider virtualization unless I can't. If I can't, then I'll consider deploying physical servers to accommodate those workloads. Well, what are some of the things that you benefit from by virtualizing the workload? Consolidation, for one thing, right? You have less metal in the data center, less power, less cooling relatively, less physical space required. You can virtualize Exchange today, okay, and you can do that with all the different server roles, whether that be the mailbox server role, whether that be the edge front-end server role. You can virtualize them all. If you want to take advantage of some of those disaster recovery capabilities in 2012 Hyper-V, then virtualizing is certainly a good idea, right? You put your machine that resides in a file. It makes things a lot more mobile. And you could also consider that you deploy the product a lot faster, right? It's a virtual machine, so you can get it out there quicker.
But let me caveat that. That doesn't mean that you use high availability in the Hyper-V stack as your high availability and disaster recovery scenario. It is an option, but realize that the platform also supports these capabilities. If I have a mailbox go down, do I necessarily want to go through the process of restoring that image? That's where you start looking at DAGs, for instance. So the DR and HA scenarios, be careful when you start looking at implementing this and only leveraging them in the Hyper-V stack. That's not necessarily best practice. You need to start considering your restore times and what your SLO and SLA objectives are in order to see if that achieves it. You know, most people, email is like crack. You take it away from them for about a day and they start freaking out. If you guys haven't got Link deployed yet, wait till you have that deployed. So it's very important to understand your end users, what the requirement is, what that C-level executive buy-in is, because typically what they think and what we think are very different. And more often than not, experience from the field, C-level and above typically say, well, hey, we can virtualize it, and I've got a cluster of hosts. Is that not high availability and disaster recovery? It is to a standpoint. You really need to understand the workload, what you're using it for, and how long it can be offline before you can restore it. And there might be better technologies specific into the product that would leverage better than looking at HA and DR with inside the Hyper-V stack.
Right. Very true. Everything Derek's saying is exactly right. You know, even companies who don't have necessarily service level agreements, if we talk to them, the one thing we say is, okay, if you don't have a service level agreement, if you had to enumerate 5 services that cannot go down, usually one top on the list, 1 or 2, is always going to be email. Can't go down, right? So even if they don't operate as if they have an SLA, they're certainly, they've got a lot of stake in keeping that service up, right? So some numbers around performance that we've seen with Microsoft Exchange. These are some internal Microsoft numbers. They're capable of deploying a virtual host with up to 12 machines running different server roles, and they're getting a heck of a lot of IOPS out of that. And they can connect to over 48,000 users, right? 48,000 mailbox users hitting the system, and they're getting some pretty significant performance numbers out of that.
Now, one of the big changes in Exchange over the last couple of releases is obviously the storage optimization requirements and IOP requirements. even from 2010 to 2013, I think they had a reduction of almost 13%, which are phenomenal numbers when you start thinking about the workloads that we're running here. That in turn has allowed us to achieve some of the scalability and start utilizing virtualization better. When you think of SANs and some of this expensive storage capabilities, does that really drive the business requirements, the upfront capital drive that as well? We're starting to see much more inexpensive SATA drives that have great throughput capabilities. Flash is becoming considerably less expensive. And even some of the hybrid storage scenarios like EMC down in the market there, where we'll give you as much flash as you need for your workload, and then we can look at offloading the other things to this cheaper, inexpensive storage.
So there's a lot at stake here for sure. So we've talked about as a workload sort of the idea of why you might consider virtualizing. We've given you some idea of the performance as well. What are some of the things that you might want to consider as far as hardware? So we're talking about how do you allocate resources to the virtual machines in Hyper-V, right? So we've got things like memory that we consider, right? You know, in Hyper-V you can now use dynamic memory, right? This is something that you don't necessarily want to consider with Exchange because the application doesn't react to recovering those resources, right? If the memory keeps changing, it's not a workload that you would want to use dynamic memory for. In fact, the recommendation and the supportability of Exchange Virtualized is to not use dynamic memory today.
Keep it static allocated. The same is with Link as well when we consider the workloads that are running. When we look at RTC streams, some of the capabilities and the utilization and the rates of them, typically when you start looking at dynamic memory, you're going to have a lot of poor performance out of these workloads, especially if we're looking at virtualizing our mediation server. We're using transcoding capabilities as well. It doesn't deal well with the scaling side of things with virtual memory, although there are other applications that deal quite well with it. It's more been the evolution of the product base. We're going to see dynamic memory support, I'm sure, as the products iterate and go forward. We've seen the supportability in some of the old products now that are supporting it in the new revs. And it's just basically trying to get the bar across the side because really virtualization, we're looking at consolidation, maximizing our resource capabilities. You know, you have a server that has 24 cores and 192 gigs of RAM. You want to be able to drive as much as you can out of that and really start seeing the ROI investments.
Absolutely. So beyond just like the memory and stuff like that, you know, with virtualization, you can overcommit resources with regards to the relation of the physical hardware that you have in the machine. You never, in an ideal scenario, you don't want to do that for simple reasons. One, first of all, the resources have to be there. So a well-architected solution should always take that in consideration. But also, if you're using virtualization to its full capabilities, you want to be able to move your virtual machines around in the case of disaster recovery and prevention. So you got to make sure that there's enough physical resources sitting on one host server as on the other, because you know at one state, at one particular time, you may have to move that virtual machine around, whether it be for DR or for purposeful, like let's say you got to patch the host. You want to do a live migration from one to the other. This is purposeful migration, not causing an outage.
Start considering the 50-50 split. And we do that in Link as well, or Exchange. When you start considering the failover capabilities, you need to make sure that your remote host that's taking over the workload has the ability to take over the complete workload. Some other things around overcommitting, though, there in Server 2012 that are pretty slick. The ballooning capabilities in startup, because a machine requires considerably more RAM resources when a machine is first booting up than once the services are started and it's at idle state. So in Server 2012, they've given you some great tools for overcommitting, right? So we have 192 gigs of RAM. We can actually set a startup value larger, and we'll start paging out, which is a capability that we've seen in Windows for a long time, where we'll write and page out to a file for that ballooning capability. Then once the machine is up, it's running its workload, and it's its idle state, typically we see a large reduction in resource requirement. So you can overcommit. 2012 has given us a lot of capabilities with overcommitting. There are specific scenarios that you need to consider with overcommitting.
Yeah.
when a machine reboots, for instance, how is that ballooning versus when a machine first starts up? They're very different, and there's some nuances around that. And number one that I see in the field, I don't know if it's the same for you, Brad, he is the private cloud data center MVP. I don't promise to know what I'm talking about. But we see a lot of people with hosts that deploy it. They forget the RAM on the host, for instance. Or they give 2 gigs of RAM to the host and expect the workloads to run properly on the host as well. What about your antivirus? What about your agent that you're doing monitoring capabilities on this? The consolidation is great with inside the virtual infrastructure, but you still need to remember the host itself, and that's probably the number one gotcha that I see more often than not with a Hyper-V deployment.
Okay. So on the hardware, we spoke a fair bit about dynamic memory. With regards to processors, we do see a lot of people sort of take the approach, okay, it's a virtual machine, we're going to give it one virtual proc. Don't do that. The manufacturer recommendation is multi-proc. For each server role server, follow the manufacturer recommendation, okay? So when you're setting up a virtual machine, if it requires 4 procs, that's 4 logical procs, set that up in the virtual machine, you consider it with your live migration, it can do the calculation and determine whether or not it's likely to succeed anyways. But the recommendation is a 1-to-1 logical proc allocation to actual processor on the box or core.
Best practice recommendation, because realize that once you start testing your workloads, an eRGP client that's 5,000 and up versus an SMSP market space that's under it, the workloads might be very different. You might find that you're able to achieve a higher count based on the workload and the requirements of the server. When we look at a Link, for instance, 32 gigs and a hex core, but that's to facilitate the max user base on that system. So, it's great when I go to a client and they come in and they say, well, what do I need to run 100 users? Well, you can do some calculations and get some basic understanding around it, but you really do need to start looking at benchmarking the capabilities as well, because you might be able to achieve a much higher consolidation than a 1-to-1 ratio.
Right. Beyond that, so when I was talking about Server 2012, the main hardware considerations are full support of what Server 2012 supports, right? So with the Exchange server roles, you can go up to a fixed VHDX file of 64 terabytes, like Server 2012 supports. You want to use separate VHDX files to split out the storage and maximize your I/O. Does support virtual fiber channel and in-guest iSCSI as well, just like the host would. If you're using VHDX format, though, no snapshots, right? That's one thing in particular. Talking about the storage on the host.
Because of the performance degradation, right? When you start getting snapshots,
right.
When you understand the disk to the master gold image. One other thing to just read out, the DVMQ. Is everybody familiar with VMQ? Lots of blank faces. VMQ, basically we're sending information directly to the hardware, to the NIC, but an interrupt is required. So we're looking at dynamic VMQ, where we might have a bottleneck with standard VMQ. Dynamic is supposed to allow us to distribute and load balance it across all the CPUs with inside the host, and in essence get around that bottleneck that might occur when we're sending high volume transactions and traffic data to that network interface.
Okay, cool. So, supports basically anything that the host supports as far as storage, anything that any resources you've got. So if you have a direct attached storage, if you're using fiber channel, iSCSI, SAS, SSD, Exchange will support all that stuff that Hyper-V does support.
Back.
So
the other thing to realize here is the Hyper-V replica, which was that last pullout.
Oh.
Exchange and SharePoint, Link. I know it's a great new technology in 2012, but again, we're talking about the workload, what's going on in real time. And when you look at how the replica works, the workload is too dynamic, especially when we start looking at the RAM copies and tagging the RAM state in host A for changed values to B. It's not really feasible at this point to look at doing that type of replica. SQL works, but not always on. It's something that you need to initiate, and there's some best practices around the link there. People can get the PowerPoint afterwards if you're interested.
Okay. So with regards to virtualizing Exchange and the considerations, just to reiterate some of the stuff we went over, We spoke about the hardware requirements, things like you can't ignore the number of processor cores. Dynamic memory is not recommended, although it is supported in Hyper-V. The application doesn't respond well to that. Disk I/O is also critical for those roles, and when you're designing that architecture, always start with the mailbox server and then work on your other server roles after the fact. Normally you see a takeaway slide at the end of the deck. The reason I put it here is because we're now going to switch gears, and we've done the virtualizing exchange portion of the presentation. We're going to hop into Link, and you're going to hear a lot more from my buddy Derek here.
A lot of this is reiteration because the workloads and how it scales and what's being utilized is fairly similar, although the concept and what it's doing is different. The workload itself is quite similar on how it loads the server. So with Link 2013, which is the first release where everything's supported in a virtualization stack, Hyper-V 2.0, I'll get into a little further in some of the further slides, but we were really limited due to virtual CPU capabilities in Hyper-V 2, where 3, as Brad mentioned, has obviously allowed us to scale up well beyond the 4 virtual cores that were available in 2008 R2. We can virtualize front-end servers in a pool, or this is an enterprise deployment. Standard edition servers will also virtualize. SQL is running on these standard edition servers. They do respond very well. Edge servers for standard deployments and enterprise deployments are fully supported for virtualization, and typically, in my experience, the number one thing that I push for virtualization. DMZs are typically underpowered and underscaled, so wherever you can get any consolidation and drive home more of a balanced array as opposed to a single server, it's more beneficial for the client. Directors are also fully supported virtual, although an optional role in 2013. If you're considering, or you're a government, or you're security sensitive, there's still a real push for directors because it's another hop between the two. Reverse proxy components, we're all familiar that TMG has been end of life a little while ago. So IS with ARR, for your reverse proxy option is great, virtualizes very well. There's some other web server products out there that virtualize very well and do reverse proxy capabilities, although I won't talk specifically on them. Know that IS and AR is not your only option. Kemp, for instance, has a reverse proxy that works very well with Link. Okay, I'll say it, Apache. I do a lot of Apache deployments with reverse proxies. Works very well. There is some nuances, obviously, with the string combinations in your expressions to make sure that you're passing the right URL information from one to the other, but fully supported and capable of doing the workloads virtual. One key thing, and it makes sense, if we're deploying an enterprise pool, you can't have a mix of resources inside the virtual environment. So if I have 4 front-end servers, 2 can't be virtual and 2 can't be physical. Because even though we start speccing out and ideally they're very close, they're about like this. So when you have a physical and a virtual, the way the server responds, the workload, it causes fragmentation across the front ends, for lack of a better word. So you need to make sure that if it's virtual, it's fully virtual. If it's physical, make sure that your procs, your speed, your capability, your bus, they're all the same across the board. Because as you start adding in differences, you're going to start noticing that the workload will respond poorly or differently than you necessarily expect it to in a virtual environment.
It's better for predictability too, right?
Yeah.
So.
Migration strategies such as live migration are not supported, as mentioned, same as Exchange, because we're dealing with such sensitive audio-video real-time communication. It doesn't deal well with the RAM copy and the disk move between the two infrastructures. I don't know where it is on the path map or whether that be supported as we go through. I don't have any more information around that on migration scenarios. So really, again, going back to the original discussion where HA and DR should never be fully considered at the virtualization level, you need to look at the product and see what's best for the workload and your SLL and SLA requirements. When you're virtualizing Link or any product, really, unless it's maybe a homegrown application server that doesn't require a lot of throughput, don't share NICs, right? If we've got a 1 gig NIC and my throughput requirements for the bandwidth are 4, and I've got them teamed, but I'm sharing link with Exchange, with IS, and another workload, you're going to start competing for those network resources. So it's important to look at even a 1-to-1 ratio for your networking capabilities, depending on the workload and the throughput that's required. That's another thing that we see very often overcommitted in virtual environments. So Hyper-V 2.0 and 3.0 are supported for link workloads. Again, realize if you're doing 2.0, Server 2008 R2, you're limited only at 4 cores. So you may be cutting your workloads almost in half when you consider that. But hey, if you're a SM/SMP or we've only got 200 or 300 users, that hypervisor might perform just fine for the workload that you're throwing at it. So don't need to go latest and greatest. You need to consider how many users, what's the throughput, how much audio and video, what's my concurrent PSTN call, all that great goodness around audio and video capabilities to really understand how much throughput processing power is going to be required for that virtual infrastructure. VMware supported. If you're looking at Server 2012, make sure that you're up to date. You want to be running 5 or later. I think there was an update for 4.x, but hey, if you're on 4, upgrade. Don't stay antiquated. Host considerations. Get away from RAID 5 and 6. RAID 5, like 20 years ago. You need to start considering how to get your spindles, get the IOP requirements, especially when we're considering highly consolidated virtual infrastructures. RAID 5 and 6 isn't great. I know it offers a level of redundancy that people are comfortable with, but you really cack out on your IOPS and your throughput. And you're offloading a lot of things to hardware, although sure, the controller will handle it, will cache stuff, but not best practice. You need to start looking at RAID 1 or RAID 10. 10 if you need the redundancy across the disks. I mean striping or mirroring and striping, depending on your tolerance for outage. SSD can be your friend, as mentioned, depending on the workload and the IOPS. You could even intermix them. Maybe put my OS on some crappy, inexpensive drives, because once they're up, it's running, and my workload's not coming off of that, it's coming off my SSDs. So definitely something to consider in the host.
Right, and this is something that's been sort of ignored by a lot of different companies, right? Storage, performance, and okay, so the vendor says this much, but I can get around it with less. Microsoft's been very good around publishing performance data and the number of spindles and sizing different products, and they'll show you things like, okay, if I've got 6 disks, how much across, if I'm doing it with SAS SCSI disks, or if I'm doing it with SSD, or if I'm doing it with 7,500 RPM SAS, you've got different specs for different products. So do take a look at that stuff. They're improving, and the documentation's getting changed pretty frequently on that, and so they're helping you to sort of get predictability around what those performance numbers will be, and will you actually see some benefit if you move away from that RAID 5 and you move on to that RAID 10 array.
Yeah, again, if you're running 100 users, RAID 5 probably work really well. Or RAID 6. Again, what are you servicing? What's the requirements? Best practices are for scale max on server. You need to consider that as well. Clients get so upset, but I'm saying if we benchmark it in a test environment and really understand what the workload is, we might be able to reduce your production costs. We might be able to reduce that hardware investment that you're making. It's funny how they come at you and then say, well, do you really know the product, what it's capable of? But the network is very different. How people use it, what they're going to be doing with the workloads are very individualized. Although there are some comparable basis when you look at it, every user is different. How they're using it, it's really good to start looking at benchmarking your workload, understanding it, and then scaling based on requirement and prod. With link virtualization, you want to look at high density core in your host. Look at the 24 cores or higher. Again, we're looking at 32 gigs in a hex core for a front-end server based on best practice max load. So you're going to see, typically you're going to hit that 1-to-1 ratio fairly quickly in most hosts, and that's why we see a lot of overcommitment occurring, because you get 512 gigs of RAM in there, but I can only get 24 cores. Well, each server doesn't need 80 gigs of RAM, but people think that the RAM is where I get my over-consolidation. You really need to look at the CPU load. And again, remember the host RAM. number one thing that usually craps out most of the deployments that I've seen or has had huge impact on the workload and capabilities. It's very important to consider what the workload is on the RAM. Antivirus. Make sure that you're starting to call out and do your exceptions. There's a lot of performance tweaking that we see that people don't do. It seems to have been lost over the decade, and we just assume it runs and it works great. But you really need to understand not only the workload for what's running, but also the infrastructure that it's running on. So some elements of link management that you should be concerned about. Did a little quick grid here specifically around link. Enabling users and disabling them, synthetic transaction capabilities in link, which we're going to get into shortly when we start talking remote watcher node capabilities with SCOM, client update, federation allowance, enabling enterprise voice, usage reports, dashboards. All our CEOs really like to see this type of data, and performance metrics are very important as well. So some elements to be concerned about when we start looking at virtualization, call quality. Again, when we look at overcommitment across the network interface, call quality can have a huge degradation in performance. Component health as well. Things that feed up to it. Although the front-end web server is this, we also know that ticketing, address book, expansion group, meeting content is all derived from there. So these are all aggregated in the new MP for 2013 and allows you to see each individual component health state and not just a server, and we'll demonstrate that in just a few moments as well. Underlying dependencies and components. Again, I mentioned link. IIS is a huge component requirement of that. SQL is a component of that. So not only are you using the management pack to look at the workload specifically, but it's also monitoring that underlying infrastructure that's critical to keep the workload up and running. Right. So when we look at link and SCOM integration, there's two flavors per se, although one's not so good without the other. There's the management pack for Link 2013, which we'll show you. It has some great views, alerting capabilities, component roll-up. As close to real time as the agent is. If anybody's been using System Center Operations Manager, we know that the health service is running scripting on the local host, and there can be some delay from when the script ran last and was successful versus maybe 15 minutes later once the script runs again and it's failed. There was that window where you didn't realize that the service was down. That's where we start looking at the remote watcher node capabilities of the management pack. You can actually have a system doing synthetic transactions against the workload. We saw this in Exchange. It's available in Link 2013 as well, where we're actually doing end-to-end peer-to-peer audio and video with test users, and it actually runs it, tries it, checks it, reports that information back and performance characteristics back to System Center Operations Manager. It's pretty slick. Rather than having your users report, hey, I can't IM A to B, the synthetic transaction will actually do that for you and report it, hopefully before your users realize it. And when you look at the scenario we have, you might even be able to rectify and solve the issue before the end user has made you aware of it, which is hopefully, ideally, where most of you guys want to be, move into that reactive state rather than being proactive and just putting out fires every day and never actually being able to move that technology footprint forward and getting some of the new benefits from the software and capabilities that are out there. So some of the things that are new in here, scenario availability and any location, synthetic transaction logs, increased reliability and coverage, IM and conferencing. Also realize that a lot of the operations management pack for 2013 is actually feeding real data from the infrastructure. So the CDR and QoE metrics database that's with Link 2013 is feeding that information directly into MOM rather than MOM discovering and doing it for you. So there's a tighter integration with this management pack than previously seen. If anybody was familiar with the 2010 link management pack and installed it, once you installed it, there was this great script you need to run to discover the roles and to understand the topology. And it was quite painful. In 2013, the management pack does this all for you. It'll build the topology. It'll even give you a nice little picture of what the topology looks like. And then, as a Visio MVP would say, export it into Visio and give that to your boss, and he can monitor it real time through services capability with SharePoint. So you can have that Visio diagram tying back and showing real state data without giving the CEO or upper level tier management access to the console. It's pretty slick. Dependency monitoring, as mentioned, big thing here. So the underlying infrastructure that's leveraged, all those prerequisites that are required, you need to have that there and available. Some of the software and hardware recommendations, just go over it pretty quick here. When we look at the Watcher node, what we need, the machine that can execute the synthetic transactions is not a link server per se. It is a trusted application that you've defined in the topology builder. It doesn't run any link workloads for the pool, although there are link components that you install in order to leverage. 8 gigs of memory, we're looking at a 64-bit quad core or a two-way 64-bit at a higher clock speed. And Windows Server 2008 R2 or Server 2012 is supported for your remote Watcher node.
Yeah.
Some of the SCOM views, which Brad is always excited about. Go ahead, Brad. Talk about the monitoring view.
Sure. So if any of you have used SCOM before, anybody using SCOM today to monitor their environment?
Oh,
Okay.
that's awesome. I don't think I've seen so many hands ever.
Nice. So a lot of what you want to do is make the information relevant to somebody. One of the things Operations Manager is really good at is reporting information. Making it specific and usable to the people is absolutely critical in the success of using a management pack. So they've already gone through and determined, how to use the views in such a way that they're easily consumed. So what they've done is they've leveraged the priority field, which usually has to do with business rules. Not a lot of management packs have done that, but things are starting to come along. Also give you things on the state of your sites, your pools, your servers. Beyond that, they start getting into the different components.
Well, first, when you look at the monitoring view, like high priority alerts,
Right.
it's out. There's a loss of service. Makes sense, right? When we start looking at medium priority alerts, this is affecting maybe an individual user or a smaller subset, but the server and the workload are up to a point, and it's not a catastrophic outage. Other alerts are more of warning alerts or things that are impacting a single individual, but are not having a complete farm impact across the organization. Sites, obviously, AD site where we're taking the pool in. Pools could be across multiple sites as well when we start talking about pool pairing, and then the servers that have been investigated and are available.
Right.
Component view, as Brad was mentioning, breaks down the individual components that are being run on the servers. So when we look at our front-end server, it might have mediation, it has the registration service, it has the web service, but it gives you the component view of that individual workload that's running on the server itself. And then the server view breakdown as well when we look at standard enterprise directors, and it gives you the health state of that server per se and allows you to drill down and see other information. This is pretty exciting. So with the Watcher node, which isn't new in SCOM, it allows you to start considering the workloads that you want to test and be aware of before your users tell you. So you can put the Watcher nodes in your LAN, across WANs. It can be domain joined. It can be undomain joined. You could use Azure as a Watcher node if you wanted to, monitoring from outside in and ensuring that federation and remote connectivity is up and running. So really testing the full user experience from anywhere in your infrastructure and understanding what's happening and being alerted on it as though the end user is calling you and say, hey, I can't IM this person, or my audio-video conference just went down. You're going to have that notification right away. One thing to realize with the Watcher node, though, natively calls every 15 minutes. I've asked some information around the product team to see if there's surfacing capabilities to make modifications to that. Hopefully I have some additional information I can share with you in the next couple of days around that, because I personally would like to run it a little bit more frequently than every 15 minutes, but it depends on your workload and how comfortable you are with risk.
Okay, so it looks like we're into the
No
demo.
more slides. We're all going to do live stuff now.
Well, I think there might be one more and then the takeaway, but that's...
No more slides.
Okay, so this is System Center Operations Manager, as I'm sure a lot of you are familiar with it. We've got the Link 2013 management pack in there, and these are those views that we were showing in the slides, right? You've got your different priority alerts. These are for alerts that come in, which are just the messages from different monitors or rules. Then we have things like your state views for your different servers that are deployed in the environment, which in our case we've got critical servers, but don't worry about that. This is a System Center lab. Yet, as an application owner or as somebody consuming the services, I don't particularly care about the server myself. I care that the services are up, right? As an IT administrator, I might care about the servers because that perhaps says something about what's going to happen to the services.
Depends on your role.
Right. So, you've got some different information in here, right? Like, say, for example, I can look at front-end server over here, and I can get some good information on things like state. So if I use the Operations Manager Health Explorer, that'll give me a good sort of picture of things that contribute to a bad health state of the server. So here, in this particular case, when I open the Health Explorer, it goes in straight away, and like a bullet, it starts going...
Only scopes the failed items.
Correct, right? So it only gives me the items that are in the worst possible state, so I can quickly see and pinpoint and get to start working on the issue. Now, if I want to get more detailed information, I can remove this scope over here, and then it'll just calculate what's inside with the different monitors, and it'll give me a much deeper picture, right? Things like anything that is basically under the targeted class for what it is that you're monitoring. So I clicked into a state view, and I went on the health state for that. So anything to do with the Link server computer and the subclasses in there. As you can see, I've got some stuff that's healthy as well. Not everything is broken in our lab. But then from there, you get availability information on things like the address book. So something in here is critical. Some address book users aren't currently indexed. But then if I look at things like expand the distribution list web service, that's in a healthy state, right? So I can get some good detailed information there as well. Now that's just based on state information. What if I'm considering things like performance? Well, I've actually got in the management pack some good information on that as well. So if I go into the components, and then I go into something like the conferencing service, I can get some good performance-based information from here as well. So if I look in, I've got some different elements that I might be concerned with. In this particular case, I've got the LS data conferencing component. Here, let me just expand that a little more.
While he's expanding, realize that you could surface this information yourself with Operations Manager. And if people have been around since earlier versions of MOM, when necessarily the MPs that were developed by the product groups were a little bit more focused, you can surface all this performance counter information yourself. The benefit of using the management pack is what takes you months or weeks, depending on the type of performance data you're trying to surface, takes you an hour and builds the rules and surfaces it right up for you. So that's a key understanding, that the MP is just doing the manual tasks that you would have to do yourself.
Right. There's a fair bit of flexibility in the product as well, right? Like we can see that I'm actually only gathering information from like yesterday, but if I want to fix the time range, I can customize it from a default of 5 days and bring that down to within the last day, and I'll make my information that much more relevant, right? Then I can zoom in and consume more relevant data that I can view more data points. As many times as the system is polling in order to collect that data, every one of those is a data point, and you can get data on it from charts and so forth. But these are just performance views that I'm demonstrating right now. Any and all components that are surfaced using the product knowledge, which can be relevant to the overall how the solution performs for you, will be in here, and then some. As long as there's an agent deployed on the server, anything that you can see on the server itself that you could technically pull from a Windows performance monitor, you can actually surface that using a rule in Operations Manager and then be able to view that in performance views. So this is pulling information from the system. I've got Link deployed. What else can I do with it? Well, in Operations Manager, I'm getting the data in the console. Those are presented in the form of alerts. And we may have some different systems set up so that if an IT person is not looking eyes on the console, they may want to know if their system's down. We call these notifications, and the number one notification system today at customers is going to be email. I'm not going to demonstrate that. That's been shown to death. But we can also use Link. It's another notification mechanism, right? So I can go inside administration, and I can set up Link as a notification channel. Right? So here I've got an IM channel set up, which basically I'm going to go and set it up with a SIP address, and I'm going to use TLS as the protocol with NTLM as the authentication and set up a port. And that will allow me more flexibility, right? So what if my email system goes down? I've now got another system which can be available as backup or as primary, depending on how I want to architect that, right? Maybe I'm going to use instant messaging as my primary notification mechanism, and I can do that using Link today. Okay, so beyond that, additional information you can get. There's also a number of canned reports that you can get to pull information on how the system's doing. So if we look in the Link Management Pack, and we want to pull information on the types of alerts that we've been getting, or how many of them, or what they're related to, I can run this report over here, and I'll run it, say, within the last week. So I'll run it from, say, Sunday. And I'm concerned with alerts from any one of these deployed servers, so I'll leave that set to default up to today this time. And I'm concerned with the top 10 alerts that may have come out of my system. So I'll let the system run that report, and I'm going to get some relevant information on how my system's performing. Stuff that, not just me as an IT pro might be interested, but if I were a manager, that I could quickly get some information on how the system's performing, right?
This isn't Link reporting as well. This is just operations manager reporting of the data that it's acquired for uptime, downtime, alerts, notifications, that type of thing. Realize that Link reporting, or even QoE or CDR reporting, is actually Link controlled, where this is just operations manager.
Right. So that's it for the SCOM demo to show. So now what else can we do with regards to System Center, right? I've shown you that we've got Operations Manager, and that's where the information gets surfaced that comes from the system. We want to know how Link's doing. Operations Manager is your diagnostic tool that you can use with System Center. But what we're also going to do is show you some extra pieces of the puzzle. What if I have a ticketing system? If I have a ticketing system, I may want to get information in there. And
one idea would be Operations Manager has now triggered an alert. There's a critical alert. If we're following MOF or ITIL practices, we need an incident now. Okay? It's great that the IT has been notified that there's an issue, but can IT necessarily action on that issue until there's an incident and a recording of how the process was done, what was the issue, how it was rectified, and then more importantly, start capturing that knowledge information and bake that into a knowledge base that other ITs can utilize in that ticketing system. Now, Microsoft has the ticketing system, System Center Service Manager that we're going to talk about specifically here. And again, we're bringing circle the idea that these products are integratable and allow you to achieve a proactive monitoring and resolution state. So rather than the IT guy saying, okay, I've got this issue, and creating a ticket manually, it would be nice if we can have this automatically generated and then start utilizing that ticket system to move forward with resolution and tracking those resolution steps.
Right. Okay. So we're going to talk about getting the information into Operations Manager and then how it goes from Operations Manager into Service Manager, so it can create those tickets or a service request to get that information from there. And I've been talking to you without showing the slide.
I wasn't sure what he was doing, but that little cue.
Right. So we'll talk about that. We'll also demonstrate an actual workflow where, let's say, you want to actually have something, some action taken from a triggered condition. So I get an incident request come into the system. I want it to take some sort of remediation. Now we know that in Operations Manager today, I can accomplish some of that using diagnostic and recovery, but you can also have some of those capabilities within Service Manager, because sometimes they're not the same team, right? Your monitoring team may be different than the team managing the help desk application or your ticketing system. And we're also going to demonstrate some automation capabilities using System Center Orchestrator and a runbook to perform those actions. We'll talk about the integration, what's involved, how to put things together, and we'll end off with a demonstration of a link problem and actually solving it. So we'll talk about that integration with Service Manager now, and I'll make sure I'm actually switching. So Derek's signals are a little too subtle, don't you think? All right, so today, if I get information in Operations Manager, I get any alert at all, that's going to come in. We're familiar with how that stuff works, right? So the information comes in, we've got an agent deployed, we have messages come in through Operations Manager, and I don't know that I have any.
I'll create some for you, don't worry about it.
Nice.
We already have some incident. As you saw earlier, there were some alerts, so we can go right into the Service Manager and actually start showing that connector and where it is.
Right.
Don't want to mom you guys to death.
So as the alert information comes through, I did discuss the capability of using notifications, right? So notifications get passed to a different system, whether that be email, whether that be link, using something called a subscription, right? So you've got a channel, you've got a subscription. Well, you can also use these things called connectors to get data between different products. And in this particular case, we're going to use a connector to go from Operations Manager to Service Manager.
Just try to reconnect that for you there, Brad. Keep going.
Okay. So in the connector, what we do is we configure using subscription information. We can tell it what kind of information that we want going from Operations Manager into Service Manager, right? Do we want all the information that comes in from the alert to the console? Customer may not be actually sitting at the console. They may want that monitoring accomplished entirely from that external system, whether it be Exchange, whether it be Link, whether it be Pager. I mean, it doesn't matter, right? Just that information has to get there from a subscription. In our case, what we've done is we've passed all critical alerts, and all high priority alerts will go from Operations Manager into Service Manager. We configured that with the connector.
Show the connector.
Okay, so that we, okay, that was in the Operations Manager system over here. So if we go into administration, we've got the product connectors over here. And we've actually created a connector to go from Operations Manager to Service Manager. There we go. The alert synchronization connector is going from Ops Manager to Service Manager. That's how we tell Operations Manager to go into Service Manager. And then from the other side, we have to tell it that it can receive information from Operations Manager as well. So, where is it? There we go. Inside the Service Manager system, we connect to read from the management server on the Operations Manager side and pull that information in, right? So it's receiving that information, and it can pass information the other way as well. So if I look in my work items, I can see that I get an incident created based on an alert that comes through. So if I go to the All Incidents view over here, based on information that comes in from Operations Manager, I'll get some data in there. We saw that we had some failures to do with Link, right? Well, this information comes in to Service Manager. In this case, we can see that this one's got a status of resolved. But
now,
the point is
one very important thing here, and I'm sorry, Brad, but this is key. With the old versions and even some of the integration capabilities, the information that was relevant and in the ticket was garbage. Like it was, this synthetic transaction failed, or this failed. When you actually start looking at the title and the information as the alerts generated from Operations Manager into Service Manager, it is very relevant to the actual failure cause, what's there, and even technically, very often, resolution capabilities and states. this management pack was very well baked. They actually gave a lot of thought of the integration and even how to surface information when we look at the connector capabilities. Rather than having to go to mom and dig in deeper, it's writing all that information into the description when it creates the IR for us. So that's very key.
Right. So these are some of the different pieces that go together, right? We get the message, we get the information into Service Manager, but from here, what do we have to do in order to be able to action that stuff? Well, what we can do is we can, in the case of the run book, we have to surface that information in the same way we connected to Operations Manager. We're going to connect to System Center Orchestrator with another connector. Okay, and that was configured under administration, but the messaging all gets performed here on the work items. Right?
This is our CMDB. So the ITIL people, the MOF, I'm trying to speak to you somewhat, although I am an IT pro, realize that the process is here. It's very relevant. And the tracking from the inception, the whole workflow, and the resolution is all stored here and then data warehoused as we move forward long term.
Right. So all this other, the information that we're going to use to take actions from the incidents are going to be these run books, right? So we've already connected to our System Center Orchestrator server. I'm going to let Derek showcase that in his demo. But just to show you from a piecemeal point of view that we need that exposed, we've got some run books defined and surfaced over here in Service Manager. I'm not going to get into the configuration. I'm going to leave that for Derek's demo, which is next, because he goes a little bit deeper into solving some of that with automation. But we also need to sort of pre-answer some of those questions that come up. Okay, so what is the condition I'm looking for? I'm looking for an incident request that comes in, and it's looking for a particular type of data. So what I'll do is I'll define a template which has some of those answers for me. Inside the incident request, I'm going to have things like affected user, what priority it is, what's the severity, what the description is.
Affected service, all that type of information and data.
Right. So what I can do is I can sort of pre-answer that information using templates over here. So what I'll do is here.
This is great. As it thins out a bit, realize that I've got some giveaways. So your odds keep going up every time somebody walks out.
So here we've defined a runbook template. If we wanted to kick off this automation directly from within Service Manager, we've already sort of pre-populated some of this. And it doesn't have to be terribly complex, right? So all we did was we defined a template here with a title of link failover, and we've actually gone through and used the runbook that's exposed through the library, and we've populated it here and said what data from that runbook will I receive that's going to be important to my incident that I will want to get in order to take action on. So we've defined, said look in that runbook, pull the ID, and that's going to be the information that the system is going to use in order to take some actions on. So this is a runbook activity template right here, and notice there's a tab called runbook. Okay. Other than that, we've created the same sort of system because we're not actually going to take this action from within Service Manager, but if I wanted to, I could. I could just go into related items, choose the activity, which I've defined over here, and go and it'll remediate the problem for me.
Not necessarily a great idea when you're talking about ITIL and MOF. Although from an administrator standpoint, hey, I don't get a page at 2 o'clock in the morning and the system fixes itself, I'm not necessarily feeling all that bad. But some upper-level management don't necessarily want the systems to empower and start self-healing themselves. They want some sort of user interaction. And that's what we're going to be doing with our demonstration. If you wanted to do fully automation, though, it's actually very capable, or even at least a workflow approval. So the alert comes into Service Manager, my Tier 3, if it's a complete infrastructure outage, makes the call and says pool failover, clicks a little button, approves it, and then it automates it. So you can go full automation where it's hands-off, it receives the alert, it rectifies it, closes the issue, closes the alert. You can have a human intervention aspect using a workflow where we can either approve or disapprove some sort of action, or we can look at more of a manual interaction or using scorched specifically to look at Service Manager for incidents, and that's what I'm going to demonstrate here. But there are multiple flavors depending on how comfortable you are with automation, maybe where you are in the ITIL and MOF framework, and even still maybe how many IT guys you have. If you're a one-guy shop for 200 people, this might be a cat's meow, a dream come true. But really understand that you can have multiple leverage, you have multiple approval workflows depending on it. The system can do as much or as little as you'd like it to do.
Absolutely. So that was, right. So now with regards to the runbook template, that's if I want to kick things off myself. But still talking about putting the pieces together, we want to react to an incident, right? So we want to actually have the system fire off a workflow, or we want to have that potential. So what we need to do to set that up is define an incident template, which is very similar in concept, right? So you just define what class it has to do with. It has to do with an incident. And then you go through, and again, you're populating that information. But it's surfaced a little bit differently because it's not specifically a runbook activity template. This has to do with incident. It's going to have information that only incidents as a work item do understand. So you're going to go and define things like
impact, urgency. In turn, it qualifies the type of issue, whether it's a level 1 issue or a level 5 issue. Very incident-related information, although it's not a service manager presentation. There is a little bit more ITIL and MOF courses later on in the week that we can make some recommendations, but understand that they are very specific depending on the management pack. Incident management is a management pack. Problem management is a management pack. Understand that management packs are a way to extend functionality regardless of the system center SKU that you're using.
Right. So it gets surfaced, the information does get surfaced a little bit differently. So you go into activities, and here you point it to the runbook. There's no runbook tab like before, right? So it's the same idea, just appears a little bit differently. And then for the actual setup where you take these pieces and you put them together, you'll do that through a workflow. So you go into here, the workflows, and you go into the configuration of that. And you're going to set up an incident event workflow. So here's where you're actually going to set up the incident template, and you're going to create it so that it auto responds to criteria. So we've gone through and we've said, okay, if you have an incident that comes through, okay, when the object is created, means when the incident comes in, we're going to specify that an incident comes through if it has any word link in square brackets in the title, take this action. Then from there, we're going to specify to apply the link failover incident template. So this is where your workflow takes all the pieces that you've defined and takes that action on it. So giving you that automation you want, because all of these things were defined and orchestrated, right? So this is how you'll set up some of the automation. So with that, I think we're going to move into the final, the orchestrator demo.
I love this stuff. Orchestrator is really awesome. Like, for instance, how many of you guys have onboarding and offboarding of users? What a great automation option. We have one client that looks at 500 to 800 onboarding and offboarding processes a year. Well, if I can have a portal receive all that information, and based on a security workflow approval, once procurement signed off, security signed off, contract signed, and they've all agreed, whether it's an email and just a yes or a portal integration, then action a task, automatically create the user, randomly generate the password, create the Exchange mailbox, assign the archiving policy, link enable them, and then send that all that information off to their manager without touching that infrastructure. Realize how much below the line work you are saving yourselves. Really start, again, getting out of that proactive mode and being able to push forward other things that make sense instead of always having to deal with that below the line weed work. Hand it off to the system. I don't know about you guys, but user creation is not exciting to me. It may be job security, but it's not exciting. So you start thinking about ways that we can leverage technology, free up resources to do exciting, cool things to push the bar forward, adopt technology and make it more utilized inside the infrastructure. That's really the key that we're trying to show here. Not take the keys away from you, but start thinking about how to leverage the technology base to allow you to do what you want to do in the infrastructure. So if this connects, if not, I'll just reconnect it.
I'll reconnect it.
I'm going to show you two runbooks. One runbook specifically will be, is it 95?
It's 85.
85. One runbook I'm going to show you here would be if Service Manager was calling the runbook, because the way that we, in essence, frame what's required is very different based on a task that Scorch is running on its own or being called on. So if Brad had implemented his runbook activity and we were having Service Manager automatically invoke this runbook to do some sort of action, this is a very simple one, but the logic is here and you'll understand it. So initialized data is important. Here's our variables. Here's our data. This is what we're utilizing through the runbook. And you'll see how this maps directly back to the activity ID that you saw in Service Manager. All I have is activity ID. That's the only piece of information I need from Service Manager in order to act upon that incident. So IR 551 is this incident where the link server failed, okay? And I can then action and move forward and gain information from Service Manager and pull it out based on that ID. So think of it as your GUID. Based on the initialized data, my first task then is to execute a CMS move. So with Link 2013, CMS is very important. If you have multiple pools and the CMS and this pool, before you can fail a pool over, you need to move the CMS over. So what I've done here, although my PowerShell friends may not necessarily think that this is the most optimal way, it is a way that I was able to utilize it. The CS move basically has some very specific parameters that we're passing along. The computer that I'm actioning this command on, the command itself, and because I chose to pull this as a execution command like CMD rather than running a .NET script like PowerShell, the integration looks a little different. I'm calling the PowerShell executable directly from its path. I'm then appending the dash command to it, which says, okay, PowerShell dash command, here's the command I want you to execute it. And I did this because this needs to run on that server, not the orchestrator server. These commands need to run there. So PowerShell, the proper way to do this would be remoting, for instance. But there are alternate ways that you can achieve the same thing, just like adding a printer, right? There's 15 ways to do everything in Windows. The working folder, where's my PS1 script that I'm running under? Very straightforward. Also, the execution mode, whether I want this interactive, probably not. I don't want people to click stuff. Think of your config man states when we're looking at this. Background normal priority or background low priority. Do we want to wait for completion? Do we just want to fire it and not care what happens? And what's my run as account that I want to execute this remote command against? Some other things in here, the security of the account to run the service, the run behavior, whether I want to do any reporting, if it didn't run, hey, if I want to change the icon. It's very pretty. It's very visual. So Orchestrator don't need to know a lot of code when you're looking at the basic capabilities that you want to do. It's very drag and drop. The data bus, you put it together and the information passes from action to action to action. So once we've executed our CS move, which is very simple, we're just invoking the database move. We have a little bit of logic behind here. For instance, this data bus here says that if the action fails, take this path, where if the action is successful, take this path. But don't do it if it's the other path. So include and exclude are very important. This is where you can start thinking a little programming-wise. Obviously, if the CMS move fails, I want an email based on it. Again, very straightforward. Subject, failed pool. We can actually subscribe data from previous steps here as well. And I'm excited about Orchestrator. If I get a little too deep, raise your hand, that's fine. But we can consume things from the previous node, like my activity ID, for instance, and publish that into the subject line. So we can start using dynamic variables or even static variables that we defined in the runbook and utilize them in the commands. Body, I haven't put anything. Hey, the subject's enough for me. and obviously the importance of the email that's being sent. You can throw in lots of optional parameters. It's very customizable. If it's not here, you can write the IP and extend it if you'd like. Again, run behavior, very common, and then general, just the name and what we're at. Once my CMS pool fails, we then look at failing over the pool itself. So again, what's the server I'm running it on? What's the command that's being executed? And this one, if I can get it to the end. Again, executing some sort of subcontext around it, the scripts. Advanced, I want it background normal. What's the account it's running under? Some logic based on success or failure. Once I've created something and completed it, going back to ITIL and MOF process, I want to tell the CMDB what was done. Otherwise, it's just me writing an email to so-and-so. But the important thing is to start capturing the knowledge in something that you can utilize and manage. So from here, we actually go in and we update that original incident that triggered the runbook. Incident, we're getting the activity ID from the initialized data. So when it ran it, that variable was passed through. We have a GUID. I then change the status to resolved. So I've actioned, the pool went down, I moved my CMS store, I failed over the box, everything was successful. I want to close that ticket now. I don't want it to be an active alert in the ticket system. On completion of that, let's send a friendly little email and say that it was all done. The flip side to that, if you can see, one is initialized data. This is if the automation activity was firing it from Service Manager, where I did it a little differently. I like Scorch being king. I like it to be independent from things. So in this run book, what's happening is it's monitoring Service Manager for a new incident, rather than Service Manager calling Orchestrator to run something based on an incident. So the connection, the incident, what am I looking for? Specifically, more important, link server front end. That title means that the NT service has failed and the pool is down. You can tailor it down very specific. There's lots of options here. Is it downtime? Is the parent? Support group, title, urgency. There's lots of flavors so that you can really focus down what you're monitoring. You might not want to just monitor any alert and action upon it because the path for resolving link might be very different than exchange resolution. So it allows you to tailor it down specifically for what you need. Again, we do the CMS move. We have some logic behind it. On success, we fail the pool. Some logic behind it. We send an email. We then close the incident, and then we send a completed email. Now, for the ITIL people that see this, they balk at me and say, hey, what are you doing? There's some process here that's still being missed. Incidents should never be a workflow item. That's a service request. So logically, if we were following ITIL, the incident should be converted to a service request before we action a runbook upon it. But it really complicates the process, and we only had an hour, so I wanted to at least give you something end-to-end to show you how the process is completed. So in a whole story, we have an incident that occurs. Operations Manager generates an alert. The alert is then fed into Service Manager, where an incident is created against that alert. Then, once the incident is there, Scorch is watching that, saying, hey, there's a new incident based on link and the pool is out. Here's the process to fix it. Actions it, goes back to my ticketing system, puts out all the information. We can even have all the output from all the command prompts also tied into that log so that there's a complete action list of everything that occurred by the system and then closes it out. That's kind of it from a complete story.
Okay.
Yeah, so for instance, the question was, could we cut out Service Manager from the piece? Yes.
Absolutely.
Scorch has an IP for Operations Manager. So rather than monitor object in Service Manager, there's an option that says monitor alert, because there's an IP to plug Scorch directly into Operations Manager. So rather than the monitor object, I could monitor alert, tailored down specific to a link, failover, high critical alert where the pool's down, and then action that same task. Yes. So IPs, Microsoft has IPs for everything that's out there. Every System Center product has an IP to integrate it into Scorch. There's also Exchange, Active Directory, user management, file manipulation, XML creation, parsing of data, every flavor that's out there. And then if Microsoft hasn't created, there's a great community around this as well, where you go to scorch.coplex.com. There's a couple of guys from General Mills that contribute to this quite actively. Great management, great integration packs in order to extend the functionality of Scorch without you having to do it yourself.
Absolutely.
Good question.
So just to tie everything together, guys, in summary, we spoke about virtualizing Exchange and Link 2013, and then we showed the management capabilities around managing those products using Operations Manager, using Service Manager, and then using Orchestrator, and we showed the integration of all the System Center products in order to accomplish those goals. So looks like we've run through our time, but we've got time for just one question, and we can do a draw perhaps if we take it outside.
Maybe 5 questions really quick.
Well, we're actually beyond the
Anybody?
7.
Is there an IP for link-specific?
Not yet. Not yet. Coming out, supposedly, but everything can be surfaced anyway.
Right. We did all that through PowerShell, right? So we took the failover.
So a remote watcher node is running synthetic transactions. Those synthetic transactions are surfaced in Link automatically. So test CS address book web service, for instance, those are baked into Link. What the synthetic transaction is doing for us is executing those test commandlets based on predetermined user accounts, state, requirement. Okay, so really all it's doing is running the Link test commandlets for you based on specific criteria that you'd like.
Okay, anything else?
Over here.
At the beginning of the session, you didn't mention in the virtualization section the virtualization of either mediation or persistent chat. Any issues with either of those?
No, supported. Watch your workload.
Don't forget your evaluations, guys.
No, if you'd like, our session's up there. We're going to export the IP, and you can take that and actually look at it and see and bake it if you'd like. Sean also is a great resource who's a PowerShell MVP. He writes them all the time. Yes, and a video recording as well.